Hello everyone. I'm going to be talking about alteration in musculoskeletal function. And this is the one that you're going to have to do on your own due to time constraints of this very heavy content class. Okay, first of all, musculoskeletal is actually two systems, obviously. When you look at it, we see muscles and the skeleton. The skeleton composed of bones and joints and the skeletal muscles. Both systems contribute to mobility. So if we have something wrong with either or, we can have a problem with mobility. The skeleton supports the body and provides leverage to the muscles so that movement of various parts of the body is possible. Contraction of the skeletal muscles and bending or rotating at the joints facilitate movements of the various body parts. So here are our objectives. And then let's move on to bone cells, which are basically osteocytes. And we have two components of those osteocytes called osteoblasts and osteoclasts. Osteoblasts are like the baby cells that are trapped within the mineralized bone matrix and help maintain it. They actually build the bone. And the osteoclasts resorb or remove. So resorb or remove old bone so that the new bone is present. And here it is, osteoblast, major bone-forming cell. It lays down new bone. Active in outer surfaces of the bone, it forms single-layer cells. Responds to parathyroid hormone, calcitonin, and vitamin D. So basically, if we have one of these missing, of these hormones and then vitamin D, we're going to have a problem with bone formation. Calcium from the blood is placed into the bone, stimulated by the hormone calcitonin. Osteoblasts produce osteocalcin when stimulated by vitamin D. And osteocalcin acts like a hormone active in bone formation. Synthesized osteoid or non-mineralized bone matrix. It concentrates plasma proteins or growth factors in the matrix and facilitates the deposits of calcium. Can sense when the bone needs to be formed. So it's actually a pretty intelligent organ. And it has a resting and an active state. Can become active after resting. And enough resting is needed, and the body knows when to elicit more osteoblasts. Osteoclasts, on the other side, or on the other hand, are large multinucleated cells. They reabsorb material from previously formed bones, so they remove old and excess bone. And then osteoblasts can rebuild new bone. They contain lysosomes filled with hydrolytic enzymes. And again, lytic, we know that prefix or suffix with lysis means a breakdown. Breaks bone into mineral components, and calcium becomes available so that it can be transported where it's needed in the body, and then the old bone just is gone. Bone renewal continues throughout life. However, we know it slows down with age. Estrogen helps with calcium uptake and release and helps regulate osteoblastic activity. So there you have it. That's why women have more osteoporosis after menopause than men. Men have greater bone density than women, and African Americans have greater bone density than Caucasians. Osteocytes, so what is that? It's a transformed osteoblast that is surrounded in osteoid as it hardens from deposited minerals, and these are our bone cells. Synthesized matrix molecules for bone calcification. Okay, so that's how bone is built. Now let's look at some definitions of different fractures, which is going to be a break in the bone of some sort. Complete fracture is broken all the way through, just like it says it's complete. Incomplete, the bone is damaged, but it's still in one piece. Tend to occur in flexible growing bones in children. Open and closed. The difference is the skin open or is the skin closed? Open used to be called compound, only if the skin is broken. And now it's just called open when the skin is broken, and closed when there's a fracture but the skin is not broken. And comminuted is when the bone is broken into two or more pieces or fragments. A linear fracture runs parallel to the long axis of the bone. An oblique fracture is at an angle. Oblique angle to the shaft of the bone. A spiral fracture is going to encircle the bone, and a transverse is cut right across of it, right across the bone. So incomplete fractures, we're usually talking about green stick, torus, or bowing. A green stick perforates one cortex and splinters the spongy bone. Name comes from a damage sustained by a young tree branch, and that's why they call it a green stick. That means a young tree when it's bent sharply. Usually these occur in the proximal metaphysis or diaphysis of the tibia, radius, and ulna. The torus is the cortex buckles, but it does not break. That's why it is incomplete. And bowing usually occurs when the longitudinal force is applied to a bone. And what that means is it occurs in children and involves a paired bone of the radius and the ulna or the tibia and the fibula. And it occurs in one of the bones. A fracture occurs in one of the bones of the pair, either the radius or ulna or the tibia or fibula. So you have a fracture, and it has such stress when it breaks sufficiently to prevent a complete fracture of the second bone, but the bone bows rather than breaks. So I hope that makes sense. It's paired. The first one or the closest one to the insult is broken, and then it's got such force applied with it that it bows the second bone, and that's why it's called a bowing fracture. So a bowing fracture resists correction or reduction because the force necessary to reduce it or to fix it, when we reduce a fracture, we fix it, it must be equal to the force that bowed it. Okay, fractures are also classified by cause, either pathologic or stress. And pathologic, we know, means disease. It's a fracture at a point where the bone has been weakened by disease, such as a tumor or osteoporosis, which is a softening of the bone, or stress due to a fatigue, insufficiency, or transchondral fracture. So what that means is a stress fracture occurs in normal or abnormal bone that is subjected to repeated stress, such as occurs during athletics. So fatigue fracture is caused by abnormal stress or torque applied to a bone with normal ability to recover. Fatigue fractures usually occur in individuals who are engaging in new activity that's both strenuous and repetitive, such as joggers, skaters, dancers, military recruits during that initial phase that they go through. This can be an imbalance between muscle and bone. Gains in muscle strength occur more rapidly than gains in bone strength. So sometimes the newly developed muscles place exaggerated stress on a bone, and that's why it's called a fatigue fracture. They're not ready for the additional stress, and this imbalance between muscle and bone development can cause microfractures to develop in the cortex of the bone. And then an insufficiency fracture is a stress fracture that occurs in bones lacking the normal ability to deform and recover. A fracture can occur as a result of normal weight bearing or activity, such in rheumatoid arthritis, which we're going to look at today, osteoporosis, Paget disease, osteomalacia, rickets, hyperparathyroidism, radiation therapy, all cause bone to lose its normal ability to deform and recover. Paget disease, just to talk about Paget's, it's a chronic disease of the bone, and it's spelled Paget. A chronic disease of the bone where it has periods of rapid bone reabsorption and growth of abnormal replacement bone, causing bone pain, deformation, so it doesn't look like a normal bone, fractures, and osteosarcoma, which is bone cancer. And then a transchondral fracture, it consists of fragmentation and separation of a portion of the articular cartilage, so that's in a joint, that covers the end of the bone at a joint. Single or multiple sites may be involved. It may consist of cartilage alone or cartilage and bone. And that's transchondral, basically saying through the bone into the cartilage. Typical sites include the femur, the ankle, the kneecap, elbow, and the wrist. And this one is most prevalent in adolescents. So now let's talk about the pathophysiology of a fracture. Let's start here. When a bone is fractured, the periosteum, the blood vessels in the cortex, marrow, and surrounding soft tissues are disrupted. We have a clot formation or a hematoma. It forms between the broken ends of the bone and beneath the periosteum. And so before we go any further, let's look at the two types of bony tissue. We've got compact bone or cortical bone. So when I say cortical or compact, that's used synonymously. And this makes up 85% of the skeleton. We have spongy bone or cancellous bone, and it makes up the other 15%. Both types of bone tissue are in every single bone. The major difference between the two types of tissue is the organization. How is it put together? Compact bone, and this is the one that's 85%, is highly organized, solid, and extremely strong. And that's a good reason for that because it makes up most of the bone. The basic structural unit in compact bone is the Haversian system, which is made up of sequencing of calcium and phosphate. It looks much like a very tightly woven basket where some of the weave is calcium and the other weave is phosphate. Spongy bone is less complex and is arranged in plates or bars termed trabeculae that branch and unite with one another to form an irregular meshwork. So bleeding occurs from the damaged ends of the bone with a fracture and neighboring soft tissue. So then we have that clot formation or a hematoma, which is the collection of blood in soft tissue or enclosed space. The hematoma forms within the medullary canal between the fractured ends of the bone and beneath the periosteum. The endosteum is a layer of connective tissue that lines the outer surfaces of both types of marrow cavity. When the tissue dies, it stimulates an intense inflammatory response characterized by, typical that we've already looked at, vasodilation, exudation of the plasma and leukocytes, and infiltration by inflammatory leukocytes and mast cells that simultaneously decalcify the fractured bone ends. Bone-forming cells in the periosteum, the endosteum, and the marrow are activated to produce subperiosteal procallus along the outer surface of the shaft and over the broken ends of the bones. Osteoblasts within the procallus synthesize collagen and matrix, which becomes mineralized to form the callus. The repair process continues, remodeling occurs, during which unnecessary callus is reabsorbed and trabeculae are formed along lines of stress as the repaired tissues bring it in line with the tissue cells of the host. We know that the trabeculae are found in the spongy bone. Except for the liver, bone is unique among all body tissues in that it will form a new bone, not scar tissue, when it heals after a fracture. So basically you have a very strong bone after you fracture it, just like it had never been hurt. Okay, I'm going to stop right there and we will go on with the second video with how are we going to repair this in just a minute.